Okay, so for this video, we will be discussing the derivative of inverse trigonometric functions. Okay, so review the meaning of trigonometric functions. So as a quick review, so let me have a scratch paper. Sorry at the back. So say for example, we have sine of sine of x is equal to y. Okay, so therefore x is equal to the arcsine of y. Okay, so that's how inverse trigonometric functions work. Okay, so but we also have another notation which is preferable. So x is equal to arc sine of y. Okay, so those two are the same. Okay, so this notation is preferred because sometimes the exponent in this notation can be misinterpreted. Okay, so it can be interpreted as arcsine of y, okay, is not equal to sine of y raised to negative 1. Okay, so that is not equal, although when we say sine squared y, that is equal to sine y squared. Okay, so this is true. Okay, so but this is not true. Okay, so this only works if we have a positive exponent, I think. Okay, so but for negative exponent, so we don't usually express it this way. Okay, so therefore this method of expressing an inverse trigonometric function is preferred. Okay, because it avoids confusion. So for the derivatives of inverse trigonometric functions, so all we need to do is memorize these formulas. Okay, for the 6 trigonometric functions. Okay, so for the derivative of arcsine of u, that is equal to 1 over square root of 1 minus u squared multiplied by the derivative of u with respect to x. Again, where u is any arbitrary function of x. Okay, that can be differentiated. So another formula, the derivative with respect to x of arc cosine of u. So notice that they are the same. The derivatives of the arc sine and arc cosine are the same except for the negative sign. Okay, so for derivative of arctan of u with respect to x, so we have 1 over 1 plus u squared multiplied by du over dx. Okay, for arc cosecant, we have negative 1 over u square root of u squared minus 1 multiplied again by du over dx. So the multiplication of du over dx is because of the chain rule. Okay, so arc secant of u, its derivative is 1 over u square root of u squared minus 1. Okay, so notice they are also the same except for the negative sign. For the derivative of arc secant, it's positive 1 over u square root of u squared minus 1. For arc cosecant, it's negative 1 over the same. Okay, for arc cotangent, derivative of arc cotangent of u is equal to negative 1 over 1 plus u squared times du over dx. Still the same with arctan of u, except that arctan of u's derivative is positive, while the derivative of arc cotangent is negative. Okay, So all you need to do is memorize those formulas. Okay, so that's it. You should memorize those formulas. Okay, so that when finding the derivatives, okay, it will be easier for you to recall the formulas. Okay, so say for example, so we have find the derivative dy over dx for y is equal to arc cosine of 2x plus 7. Okay, so obviously this is a direct use of this formula, the derivative of arc cosine of u. So dy over dx is equal to the derivative with respect to x of arc cosine of 2x plus 7. Okay, so obviously our u here is 2x plus 7. Okay, so its derivative now therefore will be negative 1 over square root of 1 minus u squared. Our u is 2x plus 7. Okay, multiplied by the derivative of u, okay, with respect to x. So the derivative of 2x plus 7, that is 2. Okay, so that's it. So dy over dx therefore is equal to negative 2 over square root of 1 minus 2x plus 7 squared. Okay, so that's it. So you can also expand this, okay, but I don't think that's really necessary. So this is your answer. Okay, okay, so for our next example, so find the derivative dw over dt when we have w is equal to cosine of arcsine of t. Okay, so this will involve derivative of trigonometric functions because we have cosine here. So the derivative of w with respect to t is equal to the derivative with respect to t of cosine of arcsine of t. Okay, so the derivative of cosine is negative sign, right? So negative sign multiplied by the negative sign of this multiplied by the derivative of this. So it will become negative sine of arcsine of t, okay, multiplied by the derivative of the function inside the trigonometric function multiplied by the derivative with respect to t of arc sine of t. Okay, so therefore it will become negative sine of arc sine of t multiplied by the derivative of sine, arc sine, sorry. So the derivative of arc sine from the formula is 1 over square root of 1 minus u squared times du over dx. So it's positive. So in this case, our u is equal to t. Okay. So therefore, it will become derivative of arc sine of t is equal to 1 over square root of 1 minus u squared. So u is equal to t, so 1 minus t squared multiplied by the derivative of t with respect to t, so that is 1. Okay, so simplifying, take note, here we have sine of arc sine of t. Okay, so we have to note that sine of arc sine of t is equal to t. Okay, so therefore we'll have negative t over square root of 1 minus t squared. So that is the derivative. Okay, so easy so far. Okay, so example number 3. So find dy over dx if we have y is equal to square root of x over arc sine of x. So here we have a fraction, so therefore we will be using the quotient rule. Okay, so therefore our dy over dx is equal to formula for recall that when we have quotient rule, so the derivative with respect to x of u over v is equal to v times du over dx minus u times dv over dx over v squared. Okay, so denominator multiplied by the derivative of the numerator minus numerator multiplied by the derivative of the denominator over denominator squared. Okay, so following the formula, so v is the denominator, so we have arc sine of x multiplied by the derivative of the numerator, so derivative of square root of x, that is 1 over 2 square root of x. Okay, minus the numerator square root of x multiplied by the derivative of the denominator. So recall again the formula, derivative of arc sine is 1 over square root of 1 minus u squared. So therefore it will be multiplied by one over square root of 1 minus x squared multiplied by the derivative of x with respect to x, so that is 1. Okay, over arc sine of x squared. Okay, and then let us simplify. simplifying this will be arcsine of x over 2 square root of x, so minus square root of x over square root of 1 minus x squared over arcsine squared of x. Okay, so maybe we can simplify so that we won't have a complex fraction. Okay, so we will add the numerators. So their least common denominator is 2 square root of x multiplied by square root of 1 minus x squared Okay, so this divided by 2 square root of x times arcsine x, so that will be square root of 1 minus x squared arcsine of x minus, so this 2 square root of x times square root of 1 minus x squared divided by square root of 1 minus x squared, so what will remain is 2 square root of x times square root of x, so therefore it will be 2x over arcsine squared of x. So therefore, simplifying, our dy over dx is equal to this square root of 1 minus x squared arcsine x minus 2x over, so we can combine this, over 2 square root of x times 1 minus x squared, and then arcsine squared of x. Okay, so it's quite complicated, so but I think that's already the best form of the answer of the derivative. Okay, so example number 4, find the derivative of arctan of x over square root of 1 minus x squared. Okay, so solution, so dy over dx therefore is equal to, so from the formula, the derivative of arctangent of u is equal to 1 over 1 plus u squared. So in this case, our u is x over square root of 1 minus x squared. Okay, so the derivative with respect to x of arctan of x over square root of 1 minus x squared. Okay, so this will become the derivative is 1 over 1 plus u squared. So 1 over 1 plus u squared. So our u is this. So u squared is x over square root of 1 minus x squared squared multiplied by the derivative of u with respect to x. So we will derive this multiplying this by the derivative of x over square root of 1 minus x squared. So therefore we should use the quotient rule. Okay, so square root of 1 minus x squared, so that's our v, and our u is x. So therefore square root of 1 minus x squared multiplied by the derivative of the numerator. So the derivative of x is 1 minus the numerator x multiplied by the derivative of the denominator. So this can be derived using the general power formula. So it will become multiplied by 1 over 2 square root of 1 minus x squared multiplied by the derivative of 1 minus x squared, so it's times negative 2x. Okay, over v squared, so over square root of 1 minus x squared, and then squared. Okay, so simplifying, so we'll have 1 over 1 plus, this will become x squared over 1 minus x squared multiplied by so here we have square root of 1 minus x squared minus or plus, so negative times negative is positive, and then we can cancel out 2, so plus we have x squared over square root of 1 minus x squared all over 1 minus x squared. Okay, so simplifying that, so we have 1 over so adding this 2, so least common denominator is 1 minus x squared, so 1 minus x squared divided by 1 times 1, so that is 1 minus x squared, and then plus x squared, okay, multiplied by, we should also add the numerator here, so least common denominator is square root of 1 minus x squared. Okay, so square root of 1 minus x squared divided by 1 times 1 minus times square root of 1 minus x squared, so it will be 1 minus x squared, and then plus x squared over 1 minus x squared. Okay, so as you can see, we can cancel out here the x squared, and then dividing this, so 1 divided by 1 over 1 minus x squared, so that will be 1 minus x squared multiplied by, here we can cancel out the x squared, right? So what will remain is 1 over square root of 1 minus x squared over 1 minus x squared. Okay, so we can cancel out 1 minus x squared, so therefore dy over dx is simply 1 over square root of 1 minus x squared. Okay, so the solution is quite long and complicated. Okay, but you should be you should have a good background in algebra. Okay, so in simplifying complex fractions. Okay, so even if the solution is very long, so the final answer is very simple, which makes this problem very satisfying to solve, I think. Okay, so that's it, I think. So let us have one last problem. Okay, so for our final problem, so y is equal to arc secant squared of square root of x, then dy over dx is equal to, okay, so arc secant squared of x, so that is simply arc secant of square root of x squared. Okay, so in this problem we will be using the general power formula. Okay, so where our u in the general power formula is arc secant of square root of x, so dy over dx is equal to, so following the general power formula, so multiply 2 in the coefficient, so 2 multiplied by arc secant of square root of x raised to 2 minus 1 multiplied by the derivative of arc secant of square root of x, arc secant square root of x. Okay, so also here I forgot to write the letter c, so arc secant square root of x. So therefore this will become 2 arc secant of square root of x multiplied by the derivative of arc secant square root of x is, from the formula, where was that? So from the formula it's positive 1 over u square root of u squared minus 1 multiplied by du over dx. So therefore it's 1 over u is square root of x multiplied by square root of u squared, so square root of x squared minus 1 multiplied by the derivative of square root of x is 1 over 2 square root of x. Okay, so therefore this will become, we can cancel out 2, so therefore this will become, in the numerator we have arcsecond square root of x, in the denominator multiplying square root of x times square root of x, so that is x square root of x squared, that is x, and then minus 1. Okay, so that's it. Okay, so basically all we need to do is follow the formulas, okay, so that we can differentiate or derive the inverse trigonometric functions, as well as usual, we should be good with algebraic operations, okay, like simplifying simplifying complex fractions, okay, and such. Okay, so good luck, and for the next video we will be having the applications, so wait for my next update.